Your AI agents have root access to your infrastructure right now, and you don't even know it.
Wait, are you saying AI automation tools are running with full privileges by default? So we're covering how to lock down AI agents, implement least privilege access, and actually audit what they're doing?
By minute 4, you'll have a bulletproof gateway architecture using MCP and OPA. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into article Building a Least Privilege AI Agent Gateway for Infrastructure Automation with MCP, OPA, and Ephemeral Runners.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's been keeping me up at night. What happens when we give AI agents the ability to execute infrastructure commands? Because this new approach to building a least privilege AI agent gateway is fascinating, and it addresses a problem that, frankly, most of us haven't even started thinking about yet.
You mean beyond just using ChatGPT to write Terraform configs?
Way beyond that. We're talking about AI agents that can autonomously provision resources, modify configurations, restart services, basically everything a human operator can do. And the security implications are, well, they're terrifying if you don't have the right controls in place.
Okay, that does sound like a recipe for disaster. What's different about this approach?
So the core insight here is that traditional access controls, service accounts, API keys, role-based access, they were designed for deterministic systems. When you have a CI/CD pipeline, you know exactly what commands it's going to run. But AI agents? They're non-deterministic by nature. They can generate novel command sequences based on context.
Right, so you can't just whitelist specific commands.
Exactly. And that's where this architecture gets clever. Instead of giving AI agents direct access to infrastructure APIs, they're using 3 key technologies: Anthropic's Model Context Protocol for standardized tool integration, Open Policy Agent for dynamic authorization, and Ephemeral Runners for isolated execution.
Model Context Protocol. That's pretty new, right?
Released just a couple months ago, it's basically a standard way for AI models to interact with external tools and systems. Think of it as the OAuth of AI tool integration. It provides a consistent interface that both AI providers and tool developers can implement.
But standardization is just one piece. How does this actually prevent an AI from, say, accidentally deleting production databases?
That's where Open Policy Agent comes in. Every single request from the AI agent gets evaluated against policies written in Rego, and these aren't static policies. They can consider context like time of day, the specific resource being accessed, even the conversation history with the AI.
Oh, so you can have policies like AI agents can only modify resources tagged as AI manageable during business hours.
Precisely. And here's what's really powerful. The policies can be as granular as you need. You could say, this AI agent can create EC2 instances, but only T3.micro instances in the development account and only up to 5 per day.
But what about the execution environment? Even with good policies, if the AI is running with privileged credentials.
And that's the third piece, Ephemeral Runners. Every command gets executed in a short-lived, isolated environment that's destroyed after use. Think GitHub Actions runners, but for AI operations. No persistent state, no credential leakage, no lateral movement if something goes wrong.
This is starting to sound like defense in depth for AI operations.
That's exactly what it is. And the timing couldn't be better. We're seeing more companies experiment with AI agents for infrastructure management. Everything from auto-scaling based on natural language policies to intelligent incident response.
What kind of scale are we talking about here?
Well, one financial services company I know is already using AI agents to handle about 30% of their routine infrastructure tasks. That's thousands of operations per day. Without proper controls, that's thousands of opportunities for things to go catastrophically wrong.
Coming up, we'll dig into exactly how they pulled this off, the technical architecture, the performance implications, and some surprising challenges they encountered along the way.
All right, so let's break down the actual architecture here. At the center, you have what they're calling an AI agent gateway, essentially a proxy that sits between your AI agents and your infrastructure APIs.
Walk me through what happens when an AI agent wants to, say, scale up a Kubernetes deployment.
So first, the AI agent uses MCP to send a tool request. Let's say it's something like scale deployment API server to 10 replicas in namespace production. That request hits the gateway, not the Kubernetes API directly.
And the gateway does what exactly?
First thing, authentication. The gateway verifies the AI agent's identity using standard mechanisms like JWT tokens or MTLS. But here's where it gets interesting. Each AI agent gets its own identity, not some shared service account.
Oh, so you can track exactly which AI agent did what.
Exactly. Full auditability. But authentication is just the start. Next, the request goes to OPA for authorization. And this is where the magic happens. OPA evaluates the request against your policies, but it's not just looking at the request in isolation.
What else is it considering?
Everything. The AI agent's past behavior, current resource utilization, even external factors like ongoing incidents or change freeze windows. I've seen policies that check PagerDuty to ensure there's no active incident before allowing infrastructure changes.
That's pretty sophisticated. What about performance? OPA evaluation can't be instant.
Good question. In their benchmarks, they're seeing P99 latency of about 15 milliseconds for policy evaluation. That includes fetching external context from systems like ServiceNow or Jira. For most infrastructure operations, that's negligible.
But what about more complex policies, like ones that need to evaluate resource dependencies?
They're using OPA's partial evaluation feature for that. Basically, you pre-compute parts of the policy that don't change often. So checking if a resource has dependencies might involve a graph traversal, but that graph is cached and only updated when infrastructure changes.
Smart. Now, assuming the request passes authorization, what happens next?
This is where ephemeral runners come in. The gateway spins up a fresh container or VM, completely isolated from everything else. It injects just the credentials needed for that specific operation, executes the command, captures the output, and then destroys the entire environment.
That sounds like a lot of overhead. How long does that take?
They're using Firecracker micro VMs, same technology that powers AWS Lambda. Cold start is about 125 milliseconds, and they keep a warm pool for common operations. So total execution time for simple operations is under a second.
What about more complex operations that might take minutes?
Great point. They support both synchronous and asynchronous execution modes. For long-running operations, the AI agent gets a job ID and can poll for status. The ephemeral runner still gets destroyed after a timeout. Default is 5 minutes, but it's configurable per operation type.
How do they handle secrets and credentials in these ephemeral environments?
This is actually one of my favorite parts. They're using Spiffy for workload identity. Each ephemeral runner gets a short-lived X.509 certificate that's only valid for the duration of that operation. Cloud providers and Kubernetes accept these certificates natively now.
So no long-lived credentials sitting around.
Exactly. And here's a neat detail. They're using open telemetry to instrument everything. Every request, policy evaluation, and command execution generates traces. You literally see the entire flow from AI intent to infrastructure change.
That's huge for debugging. What about error handling?
They've built in automatic retry logic with exponential backoff. But here's the clever bit. Retries also go through policy evaluation. So you might allow an AI agent to retry a failed deployment once, but not 10 times.
Any surprising challenges they ran into?
The biggest one was handling stateful operations. Like, what happens if an AI agent starts a multi-step workflow and then loses connection? They ended up implementing a simple state machine in Redis with automatic cleanup.
What about the AI agents themselves? How do they handle policy rejections?
That's where MCP really shines. When OPA rejects a request, it doesn't just return access denied. It returns structured feedback explaining why. Change rejected because change freeze window is active until 6 p.m. The AI agent can understand this and either wait or suggest alternatives.
So the AI can actually learn from policy rejections.
Exactly. And that brings up an interesting point about feedback loops. Stick around. We'll dive into the practical implications of this architecture and what you need to consider before implementing something like this in your own environment. So let's talk about what this actually means for platform teams, because implementing something like this isn't just a technical decision. It's a fundamental shift in how you think about infrastructure automation.
Where would you even start?
First thing, you need to map out your current automation landscape. What tools are you using? What credentials do they have? Because I guarantee you've got service accounts with way more permissions than they need.
That's probably true. We've got Terraform service accounts that can basically do anything.
You're not alone. Most organizations have overprivileged automation tools because it's easier than figuring out minimal permissions. But with AI agents, that approach becomes genuinely dangerous.
So step one is basically a permissions audit?
Exactly. And here's a practical framework. Start by categorizing your infrastructure operations into 3 buckets. Green operations, safe, reversible, low impact. Things like reading configurations or scaling within predefined limits. Yellow operations, potentially impactful but necessary, like deploying new versions or modifying load balancer configs. And red operations, dangerous stuff like deleting resources or modifying security groups.
Then you can start with policies that only allow green operations for AI agents.
Right. And here's a concrete example. One team started by allowing their AI agent to only create resources with specific tags and in specific regions. The policy looked something like allow create if resource.tags contains AI managed.true and resource.region in US East 1, US West 2.
How do you handle the learning curve with Rego and OPA?
Start simple. You don't need complex policies on day one. Even basic rules like time-based restrictions or resource limits add significant security value. And there's great tooling now. The Rego Playground, policy libraries, even AI assistants that can help write policies.
What about the operational overhead? Running all these ephemeral environments seems complex.
It's actually less overhead than you might think. If you're already using Kubernetes, you can use job resources for ephemeral runners. If you're on AWS, use Fargate or Lambda. The key is to pick infrastructure you already understand.
But what about cost? Spinning up compute for every operation?
Let's do the math. Say you're running 1,000 operations per day, average duration 30 seconds. On AWS Lambda, that's about $2 per day. Compare that to the cost of a security incident from an overprivileged service account.
When you put it that way.
And here's something people miss. This architecture isn't just for AI agents. You can use the same pattern for any automation tool. GitHub Actions, Jenkins, even manual kubectl commands. It's defense in depth for all infrastructure access.
What about organizations that aren't ready for the full architecture?
Start with just OPA. Even without ephemeral runners or MCP, having policy-based authorization for your existing automation is a huge win. You can add the other components incrementally.
Any gotchas teams should watch out for?
The biggest one is policy sprawl. It's tempting to create super specific policies for every scenario, but that becomes unmaintainable. Instead, think in terms of policy templates and use OPA's data features to externalize the specifics.
What does that look like in practice?
Instead of writing allow scaling deployment X to 10 replicas, you write allow scaling deployments to replicas defined in data.scaling limits. Then you maintain the limits in a separate config that's easier to update.
So the policies become more like frameworks.
Exactly. And here's my prediction. Within 2 years, this kind of architecture will be table stakes for any serious platform team. The combination of AI agents and infrastructure automation is too powerful to ignore, but also too dangerous to implement without proper controls.
What should teams be doing right now to prepare?
3 things. First, start experimenting with OPA if you haven't already. Second, implement workload identity in your infrastructure. Get away from long-lived credentials. Third, start thinking about your infrastructure operations as an API that needs authentication, authorization, and rate limiting.
It's really about treating infrastructure access as a first-class security concern.
Here's the thing that keeps me excited about this approach. It's not just about security. When you have fine-grained policies and full observability, you can start doing things like cost attribution per AI agent, automatic rollback on anomaly detection, even predictive scaling based on AI agent behavior patterns.
The possibilities are pretty mind-blowing.
They really are. And the best part? All the components exist today. OPA is mature. MCP is open source, ephemeral compute is commodity. This isn't some far future vision. Teams are building this right now. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from the CNCF. They've announced Open Source SecurityCon as a co-located event with KubeCon Europe 2026. This dedicated security conference is bringing together the entire ecosystem to tackle open source and cloud-native security challenges.
Security as a dedicated track makes so much sense. We've seen how critical supply chain security has become for platform teams. Are they focusing on any specific areas?
According to the CNCF blog, they're covering everything from vulnerability management to secure software development practices. It's about time security got this level of spotlight at a major cloud-native event.
Speaking of major announcements, Databricks just dropped something interesting. Lakebase, a serverless PostgreSQL database specifically designed for AI workloads.
Right. InfoQ reports it's now generally available. What caught my attention is how they're positioning this. It's not just another managed Postgres. They've built it to handle the unique demands of AI applications with integrated data pipelines and real-time processing.
The convergence of OLTP and AI workloads in one system, that could simplify a lot of architectures. No more complex ETL pipelines between your operational and analytical systems.
Exactly. And speaking of simplifying architectures, Uber just open-sourced Uforwarder, their push-based Kafka consumer proxy. InfoQ has the details on how they're solving some serious scalability challenges.
Push-based instead of pull-based? That's an interesting architectural choice.
It addresses 3 key problems they faced: scalability bottlenecks, workload isolation, and hardware efficiency. They're handling high-throughput event streams for their microservices without the traditional Kafka consumer overhead.
Platform teams managing event-driven architecture should definitely check this out. Now, AWS had quite a week according to their February 23rd Roundup.
Claude Sonnet 4.6 is now available in Amazon Bedrock, plus they've launched Kuro in GovCloud regions. The AWS blog also mentions new agent plugins, more tools for building AI applications on their platform.
The pace of AI service releases is incredible. And speaking of AI, have you seen what's happening with Kubernetes 1.35?
The CNCF blog has a great piece positioning Kubernetes as AI's operating system. Version 1.35 brings workload-aware scheduling and in-place pod resize, both crucial for AI/ML workloads.
Plus, KYML is the default kubectl output format. These aren't just incremental improvements, they're specifically targeting the needs of AI operations at scale.
Platform engineers running AI workloads on Kubernetes will definitely want to plan their upgrade strategy around these features.
That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides.
Until next time.